All right, for our trigonometry units, which, numerically we're calling this unit 9, although we're kind of all out of order this semester. Trigonometry is basically just right triangle geometry. We're going to be focusing on the relationships amongst the lengths of sides and the measures of angles in right triangles. Now, we know in a right triangle that there's one 90-degree angle and that the two other angles are complementary. All right, so they have to add up to 90. We know in a right triangle that the lengths of the sides have a special relationship based on the Pythagorean theorem, a squared plus b squared is c squared. But we're going to try to bridge that gap now between the lengths of the sides and the measures of the angles. We've had one little exploration with that in terms of our special right triangles, our 45, 45, 90 and our 30, 60, 90. But we're now going to be able to generalize that beyond just those special unique situations and deal with triangles, right triangles, regardless of the measure of the other two angles. And so our goal is to determine the lengths of the sides of a triangle using what's called the sine, cosine, and tangent ratios. Now, sine, cosine, and tangent are abbreviated nicely on our calculators using the words, the letters sin, cos, and tan. We refer to this as sine, this is cosine, and this is tangent. And so we're going to be using those ratios. We don't pronounce the abbreviation. We don't call it sin, cos, and tan. Just like when you go to the doctor's office, you don't go to the DER's office, right? So we're going to say sine, cosine, and tangent. These are just abbreviations. We don't pronounce the abbreviations. You do need to have a scientific calculator. Your phone or your Chromebook aren't going to be sufficient here. Your calculator must be in degrees mode. When we look at our calculator, you can see right above the little arrow, it says DEG. You might not be able to see that very well, but if I press this DRG button, it says you want degrees, not radians, okay? So make sure that you're in degrees mode, and that's usually the issue. If you're getting wrong answers, it's because you're using a calculator that is not in degrees mode. If you need help setting that up, let me know in class. Here's what we're going to do. Go ahead and draw that triangle to the best of your ability. Pause the video as needed, but we're going to label the legs from the perspective of or in relationship to angle A. From this angle's perspective, if I'm looking at this triangle, we know where the hypotenuse is, right? That doesn't change no matter where I'm looking from, if I'm looking from angle B or angle C or from angle A. But the legs, remember how when we did a squared plus b squared is c squared, it didn't matter which side was A and which side was B, but it definitely mattered which side was C, the hypotenuse? So that's going to be kind of that conversation that we're having here. Here I'm saying that from the perspective of angle A, these two legs, we want to be able to differentiate them from the other, all right? We didn't make a big deal out of that before. We're going to make a big deal out of it now. From the perspective of angle A, this is the opposite leg. From the perspective of angle A, this is the adjacent leg. If you need to Google what that word means, go for it. It just means next to, all right? So we have the opposite leg, and then we have the adjacent leg from the perspective of angle A, all right? However, if I'm looking from the perspective of angle B, this is not the leg that's opposite from angle B, right? I have a different perspective when I'm looking from here. I still have the hypotenuse, that doesn't change. However, I do have this leg now as the leg that's opposite from angle B. Well, before, this was the adjacent leg. Well, it's adjacent to angle A, but it's opposite from angle B. So we have to be aware of which angle we're given, which angle we're working with, so that we can concern ourselves with the task of using the appropriate number and ratio at the appropriate time. All right? And so this is the leg that's adjacent to angle B. Depending on our perspective, we'll have a different understanding of what is opposite and what is adjacent. All right? So let's talk about this first ratio, our sine ratio. Again, pause the video as you need if I'm going too quickly. The sine of an angle is the ratio of the length of the leg opposite angle A, so this length, segment BC, divided by the length of the hypotenuse, segment AB. Now, I don't need you to write all of that out, but I do need you to understand what this means. This means that, all right? This is just a shorter way of writing it. This highlighted portion is all that you need to have in the notes there. The sine of angle A is the length of the opposite leg divided by the length of the hypotenuse. Sometimes we know the measure of the angle. Sometimes it's our variable, and that's what we're looking for. Sometimes we know the length of the opposite leg. Sometimes it's the variable that we're looking for. Sometimes we know the length of the hypotenuse. Sometimes it's the length, it's the variable that we're looking for. So what we want to use the sine ratio for is when we know two of these three numbers for the measure of the angle, the length of the opposite leg, or the length of the hypotenuse, all right? Or if we know a variable for any one of these three, all right? So we either need a variable or a number for all three of these, okay? And so here's a situation in which we don't know the measures of these angles, and we're not going to find those today. We'll do that in a different video. But for here, from the perspective of angle t, I want to recognize I've got my hypotenuse, my opposite leg, and my adjacent leg. And so from the perspective of angle t, if I'm going to find the sine of angle t, I know that the sine of an angle is found by taking the length of the opposite leg divided by the length of the hypotenuse. So that's going to be my formula, and we write down our formula so that we can learn our formula. We write down our formula so we can learn our formula. We write down our formula so we can, say it with me, learn our formula. Okay, so we're going to take the sine, in this case of angle t, is going to equal the length of the opposite leg divided by the length of the hypotenuse. All right? And that's it. We have just determined the sine of that angle. It's just that fraction. I don't have to type it in. I don't need to write a goofy long decimal value. I can if I want to. It's kind of fun sometimes. All right, but that's the sine of angle t. The sine of angle u, however, has a different perspective. This is not the leg that's adjacent angle u. This is the leg that's opposite angle u. And this is the leg that's adjacent to angle u. This is still the hypotenuse, though. So from the perspective of angle u, if I ask you to find the sine of u, it's going to be the opposite leg length divided by the length of the hypotenuse. Now, these fractions are useful because we're going to use them to try to solve proportions, solve for variables. Do we not know the measure of the angle? Do we not know the length of the opposite leg? Do we not know the length of the hypotenuse? Or is that the variable that we're hunting for is really the question that we're asking. All right, so let's put that to work here on our next slide. So here, create a proportion using the sine ratio to determine the value of x. Take some time to draw those pictures. Pause the video as needed. From the perspective of this angle, we have a number for this angle. We have a number for this angle. That's awesome. We're going to be solving for those values in another lesson, and so just be aware of that, be mindful of that. But from this perspective, we have the opposite leg. Well, we don't have it, but it's what we're looking for. And we have the hypotenuse. All right? From the perspective of this angle, we have the opposite leg. We are looking for the hypotenuse. We don't have that number, but it's a variable that we're looking for. So it's important that we recognize that we have that, or at least it's findable, right? We can figure that out. So remember, we write down our formula so that we can learn the formula. The sine of an angle is found by taking the opposite leg length divided by the length of the hypotenuse. And therefore, we know that the sine of, in this case, 40 degrees is equal to the length of the opposite leg, which is unknown, that's our variable, divided by the length of the hypotenuse, 12. All right. Now, the way that we are going to solve this equation is recognize that the sine of 40 is not 40, all right? The sine of 40 has not really much to do with the number 40 other than that's the number of degrees. When you type that in your calculator, you're getting this weird, gross decimal approximation. We cannot mess with that 40. You will not mess with that 40 until probably pre-calculus or college algebra or something, maybe algebra 3. All right, but we're not going to mess with it this year. You're probably not going to mess with it next year. The sine of 40 degrees is some wonky number. The sine of 80 degrees is some wonky number. And it's a number between 0 and 1. All right, it's some percentage there of the hypotenuse. And the reason why it's some percentage of the hypotenuse is because all of the lengths of the sides have to be less than the hypotenuse. That's why your sine ratio is going to be between 0 and 1. All right? So, the way that we're going to solve this type of equation is to recognize that this is a proportion. And we just spent a lot of time in class dealing with trying to solve proportions. A proportion, again, is when you have two fractions equal to each other, and the way that you solve is you cross multiply or use some other method that you explored in your middle grades math classes. But here we're going to cross multiply. I have a strong word of advice for you, and that is do not write that the sine of 40 times 12 is equal to x. All right? Many of us are not going to use our calculator correctly if we write like this. All right? That sign button in your calculator gives us a parenthesis, an open parenthesis, and we have to be able to close that, all right? So I advise that you don't do that for fear that we might mess that up, all right? I'm looking out for your well-being here. I don't want you to have a flub with the calculator. I'd rather you have a legit math error that we can tweak instead of a calculator error that is really hard to fix. So if we go ahead and write this as 12 times the sine of 40 instead of the sine of 40 times 12, it will make a little bit more sense to us. Keep in mind that we can't make that the sine of 40 times 12. We're not going to multiply the 40 and the 12. That 40 is the degrees. That number is not going to get bigger. It's not going to be the sine of 480. All right? We're not going to do that. We're going to take 12 times the sine of 40. and then 1 times x is just x. So sorry, I didn't write the 1 times x. But in our calculators, we're going to write 12 times the sine of 40, close parentheses, and it will give us a number that is some percentage of, some fraction of 12, some value that is less than 12. It has to be less than 12 because we're finding the length of the opposite leg, that's x, and it has to be less than the length of our hypotenuse. So in this case, we have, what was that, I'm sorry, I had to put it down, 7.71, so that's going to round to 7.7, is approximately equal to x. All right, we're just going to go to one decimal place here today. I hope that's okay with you. Don't need to get super fancy, but we do need to know how to round. Over here, the sine of 51 degrees is equal to the opposite leg length over the hypotenuse. Now, over here, it might have seemed a little silly to put this over 1. You're like, why don't I just multiply both sides by 12 and then I can just be done? Right. Over here, you can't just divide both sides by 24. That's not going to do the trick. You need to put this over 1. You don't need to, but again, for safety's sake, right, to make sure that we get the hang of this first. Let's do this. We multiply, we get x times the sine of 51 is equal to 1 times 24. Now, that doesn't get x by itself, but what it does do is it gets rid of our fractions. All right, so happy day, no fractions. However, we're going to get a fraction here in just a moment. We need to get rid of this sine of 51. You cannot just divide by 51. Right? That's not going to work for us. We're then going to get a fraction. If we do 24 divided by 51, we're going to get some decimal value that's around 50%, 0.5, and the hypotenuse isn't going to be 0.5 when the leg is 24, right? It's going to be it has to be bigger than 24. So here's what you're going to do. You're going to divide both sides by the sine of 51. Now remember, the sine of 51 is just a number, but it's a decimal. It's an irrational number, maybe a little gross, but whatevs. So we're going to take 24 divided by the sine of 51, and we're going to type that in our calculator. Don't use the fraction button, just use the divide key, and it will actually give you a decimal approximation there. 30.88 is going to round to 30.9. X is approximately equal to 30.9. Okay, this was just dealing with the sine ratio. Sometimes the variables in the numerator, those are easier. Sometimes the variables in the denominator, those take 2 steps. All right? If you get quick at those, studying and applying some of those properties of proportions, go for it. That's awesome. But again, safety's sake, put your ratio over 1, and that can make your life a little bit easier. If you don't write that, you still need to understand the basics of algebra there. Multiply both sides by 12, and it gives us this. Multiply both sides by x, it gives us that. You still need to divide by the sine of 51. Here, at this point, this one's done. You just have to use your calculator. All right, next, we're going to learn about cosine. The cosine of an angle is found by taking the length of the adjacent leg divided by the length of the hypotenuse. Now, what's important to recognize is that cosine, which is abbreviated COS, is the sign of the complement. It's the complement's sign is what cosine stands for. All right, so the sine of angle B is opposite over hypotenuse. It's the same as the cosine of angle A, which is adjacent over hypotenuse. All right, you just have the same leg divided by the same hypotenuse. All right, if that confused you, don't worry about it. Write this. The cosine of angle A is the adjacent leg length divided by the length of the hypotenuse. You need to understand that this means all of that, and that this means all of that, and that this means all of that. All right, so if you want to write that down, go for it. But we are going to use those ratios to find the cosine of angle T and the cosine of angle U. The cosine of an angle is found by taking the adjacent leg length divided by the length of the hypotenuse. All right, pause the video as needed. Same situation, it's just from the perspective of angle T, this is adjacent and this is hypotenuse, this is the opposite leg. So when I'm doing cosine, I'm doing adjacent over hypotenuse. The cosine of angle T is equal to 21 over 29. I'm not going to type that in my calculator, I'm just going to write it as a fraction. Leave it as such. It's beautiful. From the perspective of angle U, however, this is the opposite leg and this is the adjacent leg. And so the cosine of angle U is 20 over 29. Now the thing that I was alluding to on the last slide when we were talking about what is a cosine ratio, being the adjacent leg over the hypotenuse, and recognizing that the cosine is the complement's sign, I want you to recognize what you wrote earlier in your notes. This is the sine of angle U, and this is the sine of angle T. I want to make sure that we keep those at least at the forefront of our mind, all right? Now, you're not going to have to necessarily understand that relationship in its fullness. However, I want you to be able to do this And if you have two angles, then I want you to be flexible about which ratio you're going to use. If you know this angle and that angle, which if you know one of them, you know the other because they're complementary, right? Then you can use that information if you just want to use sine all the time or if you just want to use cosine all the time. So you can be a little flexible with that just to recognize this information. All right, but let's use that in an example. All right, the video's getting long, but we're going to spend less time on kind of the minutia here. The cosine of an angle is found by taking the adjacent leg length divided by the hypotenuse. And so in this case, the cosine of 39 is equal to the, again, here's our adjacent, here's our opposite, here's our hypotenuse. Now, I don't know anything about the opposite leg length. So I have to use cosine here. I don't have a variable, I don't have a number, I can't use the opposite leg. I have to use adjacent and hypotenuse. From the perspective of 39, I've got these two, so that tells me I'm going to use cosine, not just because the directions told me, but if I use my head here, and if I wasn't told cosine, then I would know, well, I have adjacent, or at least a variable, I have hypotenuse, and so I can write this equation. And the way that we solve this, it's helpful, not required, to put this over 1, but if you're having trouble, put it over 1. Do yourself that favor. 10 times the cosine of 39 is equal to 1 times y. Let's use our calculators to approximate that. 10 cosine 39, whoops. And let our calculators tell us that that is 7.77. And that means I need to round that to 7.8. 7.8. One decimal place. Hope that's okay with you. If you want to be more accurate, that's okay with me as long as you round correctly. Number 2, the cosine of 50 is equal to adjacent leg over hypotenuse. Now, what I didn't do here is I didn't label the sides. All right? So if you're like, well, why does y go on the bottom? Well, you need to make sure that you understand where your hypotenuse is, opposite from your right angle. This is your adjacent leg. This is your opposite leg. From the perspective of the 50-degree angle, there's opposite. All right? So that means that this 20 is our adjacent leg. Put this over 1. When we cross multiply, we get y times the cosine of 50 is equal to 20. We need to divide both sides by the cosine of 50, not divided by 50. It's not 2 over 5. 20 over 50 is 2/5 or 0.4. We have 20 divided by the cosine of 50. So I'm going to type in my calculator, 20 divided by the cosine of 50, and I'm going to let the calculator do that work. All right? 31.1144, blah, 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 blah. We need 31.1. 31.1. Y is approximately equal to 31.1. Okay? So again, hopefully getting a little bit better at writing the ratios and then solving those proportions, just like we practiced in class already, solving proportions. All right? Again, pause the video as you need. Tangent is our last one. TAN is the abbreviation. We don't call it tan, we call it tangent. The tangent is found by taking the opposite leg length divided by the adjacent leg's length. All right? Tangent is a favorite of a lot of folks. And with my own personal struggle with focus and attention, tangents are something we frequent in my class. But here, the tangent of an angle is found by taking the opposite leg length divided by the adjacent leg length. And so when I'm referring to the tangent for angle T, I need to recognize that from angle T's perspective, I have opposite, I have adjacent. So the tangent of any angle is opposite over adjacent. In this case, the tangent of angle T is 20 over 21. From the perspective of angle U, however, this leg is opposite and this leg is adjacent. So the tangent of angle U is 21 divided by 20. Okay? Generally speaking, with any of these ratios, if they can be simplified, they should be simplified. But we don't need to necessarily type them in our calculator and write them as a decimal approximation. All right? And so just keep that in mind as just kind of a way to think through and move forward on those concepts or ideas. What you should notice is that the tangents of these complementary angles are reciprocals of each other. Okay? That the tangents of these complementary angles are reciprocals. So let's use tangent ratios to solve for variables. All right, so what I'm doing in these examples is I'm telling you which ratio to use, but what I want you to start thinking about is how do we know we're using tangent here? How do I know I used cosine earlier? Not just because of the directions, but based on what we have. From the perspective of this angle, I do not know the hypotenuse. So I can't use a sine or a cosine. Cosine and sine require a hypotenuse in the denominator. I don't know what that is. Now, you can make the case, I don't know what that is. Right, but I can find that. I at least know that it's the opposite leg length and that this is the adjacent leg length. And so I can do some work there to recognize that the tangent of any angle is the opposite leg length divided by the adjacent leg length. And so in this case, the tangent of 43 is equal to opposite over adjacent. And to solve that, we're going to put this over 1, cross multiply. 5 times the tangent of 43 degrees equals x. And then let our calculator do the thing. Over here, the tangent of 55 is equal to opposite over adjacent. All right? From the perspective of 55 degrees, there's opposite, and then this one is adjacent. All right? It's helpful to label what you've got on your pictures. If you're having trouble writing the right ratio or recognizing which side is opposite, which side is adjacent, then make sure that you're labeling it. All right? And that will help you do this part. Now, if you're looking at the picture and you can't tell, that's when you raise your hand. You ask a neighbor. All right? Here, when we cross multiply to solve, we get x times the tangent of 55 is equal to 1 times 16. We need to divide by the tangent of 55. This is not 55, it's the tangent of 55. I can't separate the 55 from the tan. All right, those are not separable. They are inseparable. Is how we would use that if we're going to use fancy pants high school vocabulary. All right, but 5 times the tangent of 43. Let your calculator do that computation. I'll put that on the screen best I can. Come on. And that gives us 4.66. Got to round it to 4.7. On the other one, we've got 16 divided by the tangent of 55. Whoops. And this gives us 11.20. So we're going to call that 11.2. All right. And then just a couple words. All right. You want to be able to ascertain the validity of your answers, the accuracy of your answers to some degree. Obviously, your calculator is spitting out answers, and so we don't know if it's right or not. Right? However, we can think about whether or not our answers are accurate. And what we can do with that is to recognize that this angle is 45, and I'm sorry, 55, so this angle has to be 35, which means that this side has to be bigger than that side. Because remember, the longer side is opposite from the larger angle. The shorter side is opposite from the smaller angle, just like we learned about in a couple previous lessons. So we want to make sure that we can see that this number has to be less than 16, because this side is across from a smaller angle than that side. Same with over here. This is 43. That means that this is 47, all right, because these are complementary angles. And so this one is bigger, longer side than this one, all right? So 4.7 is less than 5. Think about the other ones. If we were finding the hypotenuse, then the hypotenuse would have to be bigger than either our opposite leg or our adjacent leg. Our adjacent leg or our opposite leg had to be less than the length of our hypotenuse. So we can kind of think about whether or not our answer is correct, all right? Instead of just whimsically writing whatever a calculator tells us, think about whether or not our answer looks correct. We're going to have decimal answers on all of these, so we can't just blindly believe what the calculator tells us, although we kind of are doing that. We also want to pause and think about what our calculators are telling us and whether or not they seem accurate. All right, a quick mnemonic device, because this video is already over 20 minutes, I apologize, and that is, since sine of an angle is determined by the opposite leg over the hypotenuse, and the cosine of an angle is found by taking the adjacent over the hypotenuse, and the tangent of an angle is found by taking the opposite leg length over the adjacent leg length, you can have a little mnemonic here called SOHCAHTOA, and that will help you remember your sine ratio, your cosine ratio, and your tangent ratio. Sine, opposite hypotenuse; cosine, adjacent hypotenuse; tangent, opposite adjacent. All right? SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Say that in your head a bunch of times, write it on your paper. It will be helpful for writing out your formula before plugging in your values and creating and solving your proportions. Hopefully, you can process this information, think through whether or not you have the opposite leg, you have the adjacent leg, whether you have the hypotenuse, from the perspective of the angle. You have to think about the angle that you're given and what perspective you are looking at that angle from. All right? That is the end. See me with questions.